Hi, it's Mr. Fernandez. This is going to be my explain topic part 3. So we're just going to explain this question 13.2. So let's go to the variables. So question, we have a 3-inch diameter shaft and supported by a bearing of 3 inches in length. That's our L and our D, and a diameter clearance of 0.04, and is lubricated by oil that has operating temperature and has a viscosity of 5 mu Reynolds or Reynolds. Sorry. The shaft rotates around 800 RPM and carries a real load of 1,200 pounds. Estimate the bearing coefficient and friction and power loss using Pitcher equation. So basically here's the problem. This is the solution. So but basically let's see our dual diagram here. We have diameter is 3, length is 5, our radius is whatever diameter divided by 2 is, so that's 1.5. Our clearance is 0.02 because since we have 0.04, we need divided by 2 to have 2,000 of an inch on each side. And we can see our SEA oil at viscosity of 5 million Reynolds or Reynolds. Yeah. Our rotation is 1800 RPM. Assumptions: our load creates negligible eccentricity between journal and bearing, so that's how eccentric it is, and measurement, lubricant flow, and axial direction. Yeah. So those are assumptions. Let's go to an analysis. So let's calculate our load intensity. So that's P equals W over LD. The way I like to think about this is that you have a force going on down here. You want to see how intense that load is around this shaft here. So you have to take your diameter and your length, and you're basically spreading across that whole diameter length when you multiply these two values. So it's 1,200 pounds over this area. So then it's 1,200 divided by 3 times 3, which gives you 133.3 psi. Now we are going to use Petrov's equation for viscosity. So we have F equals 2 pi squared mu n over P times R over C. So we have 5 times 10 to -6 Reynolds. This is a bit different from what you see here because this is a mu Reynolds. So you have to do anything in mu. If you see mu, just do 10 times -6. And then you convert 1800 RPM divided by 60 to get 30 revs per second. And your P value right here is just taken from here. And then 1.5, that's a radius, so 3 divided by 2, so 1.5, and then 0.02 inches, your clearance right here. So that's 0.04 inches divided by 2 equals 0.02 inches because you have to do 0.2 inches here, 0.2 inches here. And then when you calculate all the value, slap in your calculator, you get 0.0167 as your S value. And now we're going to calculate our friction loss, our bearing coefficient friction loss, or TF value. So TF equals FW over R times R. So you have these values again, 1,200 pounds from up here, 1,200 pounds in the question, 0.067, that's here. At 1.5 for your radius is right here. Multiply all together, you get 29.98 inch pounds because this is an inch and it's pounds and this is constant. So then you want to switch that to foot pounds. So what you do is 29.98 divided by 2, or 29.98 divided by 12 because 1 inch equals 12 feet. So then you get around 2.4988333, which is really just 2.5 foot pounds. I personally I would keep the big number, but when doing these calculations, because it's accuracy, but it says 2.5 foot pounds here. Power loss. So we calculate power loss is just the TF value or your torque value times your rotations per minute, or rotations per minute or revolutions per minute. And this is just used to convert to a horsepower. So you put 2.5 times 1800 and 5252, and you get 0.856 horsepower. So how can you verify this number, or at least this number? So what we want to do is we want to go to the chart. So you pop this chart open, 13.14 or 13.14, and then you can look here. So this is your 13.14 graph. See if we go with 13.14, and basically you say L divided by D, that goes 3 over 3. So you look at these graphs, you're like, oh, okay, L divided by D, that's quarter, half, 1. Okay, 1. We have 1 here, so that's what it'll be. So you know it's going to be something around this on this line. Now you just got to figure out its x and y's. So where on this line are we going to be at? So you do S, you solve for S. You have R, you have C, you have mu, you have N, you have P. So you put that in this equation here, and it pops out the S number. In our case is 0.622. So we go here on our chart, we go 0.0, 0.1, 0.2, we go look for 0.6 until we get here, boom, we're at 0.6. Now we're about a bit above it, so we'll go 0.632. We go up until we hit here, which is around, 1 second, I just hit here. Yeah, around here, which is around 0.6. And then now we just go across. Bam, and we get around here, which what they say is around RCF equals 13. So how do we solve now for F? So we say we make this equation R divided by C times F, that equals 13. We have R, we have C, so we have F. We don't have it, we're solving for F. So we equal that to 13. So this would be 1.5, this would be 0.02, and so we equal 13. So we take this value, we pop it, we divide it by 30, we make it 13 divided by this value, and then we'll find our F value. So you do 13 divided by 1.5. So 13 divided by 1.5 divided by 0.02, and you get 0.0173. And that's how you got F equals 0.01733, which is 4% larger than 0.16667. But this is more of an estimate because you're using a chart. So any little inaccuracies will make this a bit wrong. If you use 12, for example, instead of 13, let's see what we get. We get 0.1666. So it really depends on how you look at the chart. But yeah, that's a nice explanation. Great. I hope you learned something. Have a good day.